we are continuing our learning on percent, and today we're going to learn the percent proportion, which is my favorite way to solve percents. So I'm super excited. You probably aren't, but that's okay. First thing we're going to do is determine the unknown quantity in each proportion. This is the same as making equivalent fractions, guys. We've done this with ratios and fractions for a while now. So you should be able to find the missing number. Any questions? You have 3 of them, so I'm going to give you about 4 minutes. Go for it. Okay, guys. So we're making equivalent fractions. Can I do something to 8 to get to 12 evenly? No. But can I simplify my whole fraction where I have a numerator and a denominator? By what? 2. So if I divide both by 2, that gives me 3/4. Now can I do something to 4 to get to 12 evenly? What? Times 3. So 3 times 3 is 9. That is my missing number. Make sense? All right. Number 2. I always have to start where I have a numerator and a denominator. So this time I'm starting behind the equal sign. Can I do something to 40 to get to 16 evenly? No. Can I divide or reduce or simplify 15 over 40? By what? By 5. And that gives me 3/8. Now can I do something to 8 to get to 16 evenly? Times 2. So 3 times 2 is? 6. All right, can I do something to 15 to get to 10 evenly? No, and not unless I use a decimal or a fraction. So can I simplify 6/15? 5, 3, and that gives me 2/5. Can I do something to 5 to get to 10 evenly? What? 5 to 10, guys. Not hard. Times 2. So 2 times 2 is? 4. Any questions about this one? Okay, because we're going to be using this in our lesson today. So let's turn to the next page. Five. All right, when you study problems in terms of ratios, like percent, it's important to think about the whole as well as the parts. The whole is not always 100. Every group you have does not have 100 things in it, right? I could have a whole group of something and it be 10, or a whole dozen eggs and it be 12. So the whole does not always have to be 100. Does that make sense? Yep. Okay. So if the whole changes, it also changes the percent. So that's what we need to keep in mind today. So let's look at A. If the picture shown is 100% of the triangles, draw 50% of the triangles. Okay, and if the picture shown is 30% of the triangles, draw 100% of the triangles. So I want you to work on A and B, and we're going to give you about 4 minutes to answer both of those questions. Got it? Good, go for it.
Okay, on our first one, you have to realize which way it's going. So we really want you paying attention to the verbiage. So this says this picture is 100% of what it is. So I need to draw 50% of it. So 50% would be how much of it? Half, or 3 triangles. Okay? Now, this one changes it around. It says, now your picture, this is only 30% of everything. So now I need to draw all the rest of it. I need to get it to 100%. So when I looked at it, I said, well, okay, if this is 30%, that means each 2 is 10%, correct? So for my whole picture, I would need to end up drawing 20 triangles. So I would do 10 on top, 4, 5, 6, 7, 8, 9, 10, and then I would do another 10 on the bottom. 3, Make sense? Okay? So this one was saying, here's the whole picture, draw me half of it. This is saying, okay, that's only part of the picture, what does the whole thing look like? But everybody seeing how that goes now? Okay. So now that we've given you the example, we want you to do the next three and see if you can figure those ones out better. So now we're looking at, this one is 25% of the whole figure. So if that's 25%, now I need to draw a rectangle that's 50%. So what am I going to do to it? It starts with, what's my relationship? How do I go from 25% to 50%? Then, multiply by 2. So I'm going to take the rectangle, and I'm going to draw two of them side by side. Okay? Now we're going to draw a rectangle that is 75%. So now what am I going to end up doing? Draw three triangles.
Not triangles, squares.
Rectangles, there we go. So, the way I did it and saw it was like this. A lot of you may have seen it this way, that's fine. Either way works as long as you've got three of them represented. And then our last one, draw a rectangle that's 100%. What do you think? Four of them. Make sense? Okay. So you're starting to get the idea, which is good, because I was looking at the homework, a lot of you missed the benchmark piece. Benchmark is just breaking it into pieces, which is really what this was. It's saying, can you recognize the different pieces and then put them back together to get your answer? Yes? I'm sorry?
It says any one more than one or two. The rectangles have a laundry and not two separated.
Right, but if I put them together, then it becomes a bigger rectangle. That's just showing how you're putting them together. Okay, let's go to page 284. We're going to skip a page. Mr. Goodwin. Math classes determine 25% of 44. We have 5 different students responded with their strategies. We're going to talk through all 5 of them to help you understand them. Kendra starts out. She says, since 25% of 44 means multiplying 25 times the quantity, I used the fraction method. So she turned the 25% into a fraction using the definition, which is it's out of 100. So that was actually her journal entry. All I do is I take the percent, I put it over 100 to make it a fraction. And then she simplified to 1/4. Once she simplified, then she said, okay, it's just 1/4 times 44, and the answer was 11. Does everybody understand the process you use? Does it make sense? Okay? So, our next one, Hank said, I like decimals. So, I'm going to take the percentage and turn it into a decimal, 25 and then I'm just going to multiply that 25 times 44, and I get 11. A lot of you that your parents helped you on your homework, I saw a lot of students that did this instead of benchmarks. Okay? So, that's a very valid method to do, but it was one we were waiting one more class period to show you. Ryan said 25% is easy to do in my head. So, if I know 50% of 44 is 22, I just divide it by 2. And 25% is half of 50%. So 25% of 44 is half of 22, so that equals 11. Does that make sense? Carmen? Does that make sense for everybody? Okay. Simon, he just said, wow, 25%, that's the same as a 4. So I just divided by 4, because multiplying by 1/4 is the same as dividing by 4, makes it 11. Pamela says, I prefer the benchmarks. So, for all of you that didn't do your benchmarks last night, watch again. Here's another chance for you to see how this works. She said 10% of 44 is 4 4/10. 20% is 2 of those. So that gives me 8 8/10. Then 5% is half of the 10, so that's 2 and 2/10. So I put those two together and I get 11. That's how you're supposed to use the benchmarks, guys. You break it into ones that are easy to do. Everybody makes sense on this? Okay? So for all of you that didn't do your benchmarks, that is the concept. Break it into the pieces and then you put those pieces back together. Okay. So now we're going to discuss each method. This is Mr. Chan's favorite part. Kendra's method. When is this? And here's your key. Most efficient. So when do you think it'd be easiest to use Kendra's method? I'll give you a hint. What did she do to her fraction right away? Simplified it. So if it's easy to simplify, the fraction, the percent into a fraction. There should be a C in there. So if I get it so that the numbers work well together, then her method can work. But that takes really good number sense and understanding how that percent can be simplified to a number that's going to work well with the number I'm using. What about Hanks? He's the one that turned it to a decimal. What do you think? Find something? Okay. It is good. I'll be honest, guys, Hanks is probably the most efficient overall because it's really easy to turn percent to a decimal, right? So all I do is move my decimal twice. So his is most efficient, honestly, if it's in an even number like 10s, 20s, 30s, because then it's just multiplying by one number. But anytime the percent doesn't simplify as a fraction. So this is going to be by far the most usable one. Yes, as the numbers are more complex. Thank you, Mr. Chan. That's probably a better way to say that. I'll even add that up here. So if you're looking at harder numbers, then the decimal way is going to be the easiest. Because remember, multiply decimals, guys, all you're doing is you're multiplying the numbers and then putting those decimals into your answer. So it's actually quite easy. Ryan's method. Ryan was the... Oh, so he basically used your benchmarks, right? So when is his going to work? When it's right at a benchmark.
Guys, you should be writing this. He's not doing it because he needs to remember it.
So if it's one of those benchmark percents that's easy to do, then Ryan's method is going to work. When is Simon's most efficient to use? Then? Why? There is a huge caveat to Simon's method. What is the caveat? When is it most efficient? Good, when it's a super easy conversion, right? So his is limited to super easy conversions, easy fraction conversions. But if it's a super easy one, then his will work. But his is really going to be very limited. What about Pamela's? She's the one that used the benchmarks. So it's actually going to be kind of like the first one we did. When it's right at a benchmark is going to be the easiest. At a benchmark. In other words, if it's right at like the 1%, 10%, 25%, that's going to be really easy to do. So if that any of the right at one of those benchmarks, that's going to be easy. So like if you're doing 8%, that's not at a benchmark, so it's going to be a little more complex. You're breaking the number down a lot more. But if it's a 10%, then that works super easy. Any questions on these types of methods? So here's the big deal, guys. We've just shown you 5 different ways to make these conversions happen. So we're giving you a whole lot of options. One of the big pieces that we need you to do is figure out which ones work best for you. But realize that some of these methods do come with limitations. Okay? So I do kind of agree with Ben that the Simon's method is nicest if it hits one of those benchmark percents. It's easy to make a fraction. But we're going to be doing a lot of numbers that aren't super easy fractions. For example, Mr. Good now says, well, what's 32% of 732? Now all of a sudden, everything changes because these numbers aren't going to be as easy to work with. Well, let's look through. Each of them is still going to be able to do it. So Kendra says, my fraction isn't quite as easy this time because I'm going to take my 3200ths, change it into a fraction. I can simplify 8 and 25, but that still gives me 5,856 over 25. Yes, I'm magic. I can change the fractions into people. And I get a decimal answer after I actually divide that all out. So her method is going to be a little more complex in this instance because those numbers don't work together as well. Hank says, you know what? Mine's really not any more difficult. I just change it to a decimal, move my decimal place over twice. So it's 3200ths times 732. You literally just do the math. I'm multiplying 732 by 32 and then putting 2 decimals in my answer. Relatively easy and very consistent. So Hank, I'll give you a hint, is a really good method. Ryan says, I can still estimate, but my answer is going to be close but not exact. So like 32% is close to a third. A third of 730 is 244, but that's not going to give you the exact answer. So Ryan's already quickly falling by the wayside. His method is going to be very limited in when you can use it. Simon, I don't have an easy fraction to use for 32%. So my method isn't going to work. So again, where I agree with Ben that if it works, it's nice. Most of the time, Simon's method is not going to work so well. Pamela says, I can still use my method. And I actually agree with Pamela, and after doing this benchmark percents the last couple of years, I'm becoming a bigger fan of them because these are actually really easy to do. I can say, okay, 32%, that's all I do is 10%, move my decimal once, but I need 3 of those, so I multiply it by 3 to get 219 and 6/10. Then I need 2 1% to get the 2% out of the 32. 1%, I just move my decimal twice, so that's 7 and 3200ths. I multiply by 2 to get this number, and then I just put the 2 together. So it is a little more work overall, but the math itself is actually easier in a lot of ways. Okay? So the bottom line on this one, though, to me is Hank's method is still going to be the best, but we're going to give you guys a chance to talk right now with your table mates. Talk about all 5 of them. Okay, so we'll get to talk. And we're going to have you guys, you don't have to do DEF, but we do want you to pick one of the methods and determine the percent of each quantity. In other words, tell me what 7% of 80 is, etc. So we'll give you guys about 3 minutes to do those 3 problems. Go.
Okay, who can tell me what strategy they used for A? Hanks, he turned it into a decimal. So how do I turn a percent into a decimal? To the left how many times? 2. So my decimal point is always after the ones place. I move it twice to the left and put 0 in my empty bucket. So now I have 700. Yes? And I am multiplying that times my 80. So 7 times 0 is? 7 times 8 is? How many numbers did I have after my decimal? 2. So I should have 2 numbers after the decimal in my answer. So I get 5 and 60/100ths. I did not need to multiply by the 0 because it's not going to change my answer. Anything times 0 is 0. All right, who can tell me the strategy they use for B that's not case? Pamella's broke it into benchmarks. So here we would need 3 10%, 1 5%, and 2 1%. Yes? So what is 10% of 120? How do you find 10% of a number, guys?
12.
You move the decimal one place to the left. So 12, but I need 3 of them, so that's 36. If 10% is 12, what is 5%?
6.
6, because it is half of 10%, yes?
Yes.
And how do I find 1% of a number? Move the decimal twice to the left. So I get 1 and 2 tenths. I need 2 of them, so that gives me 2 and 4 tenths. So my answer is 44 and 4 tenths. Yes?
What is it? What? You sent out to me that.
Which one?
The one you did. The one number. No, it's the me, but he didn't wear.
Haha, I did the wrong problem. Okay, so here, 10%. Y'all could have said that a long time ago, guys.
I said it. I was getting confused.
So 5.5. What is half of 5 and 5 tenths?
Half of that is 2.20, 2.75.
2 and 75. So that gives me 8 and 25/100ths. All right, I am going to pick the last method. How do I change a percent into a fraction?
Put it over
Put it over
100.
100. And I know I'm going to 300 because it says of. So what do I do to get to 300?
24.
So 8 times 3 is
24.
24. Any questions?
No, ma'am. No, ma'am.
If you did it as a decimal, it should say 24.00. You have to have a decimal in your answer if you have one in your problem. Make sense?
Yes.
Okay, turn the page. Mr. Moore, you may want to do this because we have 14 minutes left and you talk a lot faster than I do.
Oh, you're going to speed
I mean, I don't disagree, but we need to get through it.
So on this one,
Faster he has to talk.
yes. They're raising money. So far they've done $240, but at 60% of the goal. So Kendra said, okay, double number line. I really like those because it's really easy to visualize where my numbers are. So she did it, the dollars versus the goal. And she said, okay, obviously we started our 0, 0. I'm doing percents. So that means my bottom is going to be out of 100. Since I'm doing 60, the number I know is my 60 and 240. So I will put that number on my double number line. But in order to figure out the 100%, will 60 go easy to 100? No. So she says, well, the first thing I'm going to do then is figure out what my 10% is. So how does she go from 60 to 10? Divide by 6. Realize I'm going down. So what is she going to do to the 240? Divide by 6, and she gets 40. So how did she determine the value that corresponds to 10? She divided by 6. Okay? So if 240 is 60%, what's 100% of the goal? So now how am I going to use your double number line to get to 100?
Divide by
Guys, I now have 10 and 40, yes?
oh, multiply by
So I multiply by 10 to get to 100, so that means I take my 40, multiply by 10, and I get 400. So, multiply 10% times 10 for 100%, and $40 times 10 for $400. Make sense? Now, here's our big one. Which way of reporting is more informative? In other words, what actually gives you more information? The amount of money she raised or the percent of the money she raised? In other words, what actually tells you more about what they're doing? If I tell you they raised $240 or if they're at 60% of their goal? What do you think?
You could say 60% because if you just say they raised $240 and she never said how much like money she raised total, then you don't know how much more she used.
But as soon as I say 60%, you kind of know where they're at, right?
Yeah, it's more than half.
So the more informative is actually the 60%. Because it gives us an idea of where we're at. And this, guys, is the huge advantage of percentages. Just by telling you percent, you get an idea. Am I way low? Am I in the middle? Or am I way high? The percent alone tells you that. Normally, you're going to need additional information to get a fuller picture of what's happening. But the percent itself is going to give you a really good idea of where you're at in relation to the whole. Which kind of gets us to our next part. Because really, all percent is telling you is a part to a whole relationship. It's helping you set up a proportion. So, Carlos is told that 65% of the students, or 78 students, prefer pizza for lunch. But he wants to know how many students participated in the survey. So he started with a double number line, and he said, okay, I know the number of students, and I know the percent, and I know that at 65% it was 78, but I really want to know what the whole was. Well, the good thing is we know a whole percent is how much? 100 out of 100. So if I want to know what the whole is, I know it's out of 100. I can just change my percent to 100, correct? And I know that the part was 78. Well, the part is 65. You always put the parts together, yes?
Yes.
And I know that, but I don't know what the whole was. That's what I want to find out. So what he said was, okay, well, I have this proportional relationship set up, but 65 doesn't go directly to 78, does it? No. But I can simplify 65 and 100. I can divide them both by 5, give me 13 over 20, and then I do 13 times 6, and I get 78. So I do 20 times 6, and I get 120. Make sense? So a lot of times, if you don't know directly how to get there, see if you can step back to get there to make the math easier for you. Okay? So, how did he do it? He stepped back to 13 over 20 to go forward to 78 over 120. And we showed the math above in the example. So a lot of times, that should be your first option. If you don't see a direct relationship between the numbers, see if you can step back. Unfortunately, you're not always going to be able to step back, which gets us to our next one. Okay? Oscar said instead of scaling down and scaling up, it's more efficient to scale up from the start. So if I use my proportional setup, I know that the 65, this is where he started, so he knows he's going 65 to 78, right?
Yes.
But he doesn't know what number he used. So instead, what he's going to do, if I don't know what I'm multiplying to go up, I can always use that relationship going back down and divide. So instead, all I'm going to do is I'm going to take 78, and I'm going to divide by 65. Well, 65 goes into 78 once. Divide 65 gives me a 3. Here's a major concept that a lot of you still seem to be struggling on, because we're in middle school anymore and we don't do remainders anymore. Okay? Instead, we add a decimal and a 0. So I add a decimal and a 0 that I can now bring down. 65 goes into 130 twice. And now he understands what I multiplied by was 1 and 2/10. Does everybody see where we got that number now? Okay? And again, it comes down to, if I don't know what I multiplied by, I can divide to figure it out. Because I know that there is a relationship between those numbers. So then he does the 100 times 1.2, and he gets the 120. Okay? So now we want you to use that method to solve this problem. Okay? I'll give you a hint. 45 times a whole number doesn't equal 126. So you're going to divide 126 by 45, figure out what number you get. Yes, sir.
Which one are you going to give us?
Like 2 minutes, since we have 7 minutes left in class. So I need to go home. Okay, so 1 minute. Class. Okay, I know a lot of you did not get it done yet, but all I'm doing is I'm taking 126, dividing by 45. It won't go into 1 or 12. It's going to go into 126 twice. Subtract 90 gives me 36. Still not at 0, so I add a decimal and a 0. It's going to go into 368 times. 8, 40, 32, 36, yep. So, it's 2 and 8/10. So I now know that my factor was 2 and 8/10. So I'm going to multiply 2 and 8/10 times 100. And that means I just moved my decimal twice. So the answer is 280. Okay, let's go to our homework. So we need to go over that real quick. Page 297. Please quiet down so that I can go through this. They did give you, we didn't get as many practice in this as we would hope, but realize this whole concept comes down to, I compare the part to the whole, is my percent over 100. They've given you a table to complete. So all you're going to need to do is fill in the blank pieces. I will give you a hint and I'll say this is your part. This is your whole. So that will help you to set up the percent fractions if that's the way you choose to do it. Okay, this one, they sold 12 jazz downloads. That made up 2% of the total sales. So to determine the number, all I'm going to do is set this up. Here's another hint. That's your part. Okay? Suppose it sells 14 jazz songs and it's still 2%. Total number, guess what? That's still the part when you set up your proportion. Go to 298, or is it down below? Let's see. Try to put it all on the same page. There we go. Here's where, excuse me, we didn't get as much practice in today. You're going to calculate them. All of these should be set up as a part over the whole equals the percent over 100. So whatever number is in front of the percent is always going to go here. So they made that part easy for you. We didn't talk about it, but if it says is, that is the part. If it's the number after of, that's the whole. So is and of are your two key words to be able to set these up correctly. Okay? The number before is your part. The number after of is your whole. Questions on your homework. Okay, once you have your proportions set up, then you're given options. Most of these numbers, a step back is going to work well for you. There might be a couple where you're going to feel like dividing it out to find your scale factor will work better. But all 8 of these need to have some type of proportion set up so you'll be able to solve them. Any questions on your homework? Okay, good luck, guys.